Arigato. Can you hear me? Hello, can you hear me? Yeah, okay. Just sending a message in chat so that I'm starting now. If everybody wants to join. All right. Let's see. All right, how everybody's doing? Hope everybody's doing well. Okay, everybody see my screen? Okay, so I'll review where we are. All right, I believe we had just started the 8th week. Week number 8 right here, where we had we started talking about Node.js and creating an HTTP server. I believe that's what we did in the previous lecture. So we're going to continue working on that. And so today we're going to introduce how are we going to integrate our React application with this RESTful HTTP server. Okay, so that's going to be the focus of today. Later on, not this week, but the following week, we're going to introduce databases, how to integrate the changes that we make and maintain the state in a more permanent form, right, by using a database. We're going to be looking at Mongo. It's a non-relational database, oftentimes referred to as a NoSQL database. Certainly, there are many other options. We use SQL databases, object databases, all different types of databases, but the more common ones are relational SQL databases. But today, we're going to be using a non-relational database, NoSQL database called MongoDB. That will be the focus of next week. So let's review what we worked on last lecture. So we created a server here in app.js. That's the entry point of our server. And we said that this was a server that was implemented using JavaScript so that we can run it with the Node.js JavaScript interpreter on a desktop. Right? So we can run this using Node and then providing this JavaScript file, app.js. And what the app.js is doing is importing a library called Express. And Express is a very popular library for creating HTTP servers. Right? It allows you to, just with a few lines of code, be very, very productive and create a server that listens at a particular port. Right? And a server is just a piece of software that we can program to react to incoming network connections. Basically, that's all it is. Right? You have a machine that is listening at a at the internet connection, and we can program what happens, right, when connections come in, right? What to do. We can the most common use is for retrieving files, right? That's where it all gets started. Right? We want to be able to instead of us having each computer keeping track of its own files. Right, at first there was no the machines were very not powerful at all, right? And so we had these dumb clients that had very little RAM, maybe just a screen and a monitor, but the actual information or file storage or data and computing power was at a central place. Right? So we needed to create these network connections to go fetch these documents, right, and copy them over so they could be displayed or at the terminal level. So we, in this architecture of distributed computers, right, are talking to one another, we need to be able to programmatically, right, the configure what an application or what a computer will do when it receives these commands, through a network. And there are many different protocols for different purposes. One of the first use cases was to transfer files. Right, they had these centralized machines that were holding files for everybody else that were waiting for incoming requests from other machines to please fetch them a particular file. Right, so that protocol of how to ask for files, receive files, update files, delete files, right? That was the FTP protocol, right? File transfer protocol. It's one of the earliest protocols that were designed for machines or servers to, as one of the first use cases, right, for these network connections. Another one that became very, very popular as well is sending messages, sending email, right? That where someone can send a message with a from and a to, right? And then you have all these machines in a long chain that once the sender broadcasts this email, machines can then route that message to the recipient. Right? So there are all these different protocols were designed over time. Eventually the one that we ended up using for our own that Tim Berners-Lee designed and implemented was the HTTP protocol, right? That was for transferring files, just like FTP, but there were files of a specific format. That they were ASCII files. They were not binary files like images, PDF documents, and things like that. These were ASCII files, just text files that were formatted as using the HTML or hypertext markup language. Right? So he came up with this HTTP protocol. And what part of that protocol was that copying or inspired by other protocols, right? We wanted to be able to do certain things with these files back and forth between the servers and the browsers, right? We wanted the browser to be able to retrieve an HTTP document or update an HTTP document or delete a document, right? And so he designed this put, get, post, delete methods or operations that you can specify as part of the message that goes between the client and the server, right? Where you send a request to the server, client browser would send a request to the server, and that message has a structure, right? It has a header, it has a body. And in the header, you have control mechanisms that kind of tell the server how to interpret the message. Right, so it's a put, it's a post, it's delete. Okay, and then plus parameters that you can pass in, any attachments to the document that would be available in the body, You can attach all sorts of things. You can attach images, PDFs, and whatnot, all available in the body. So today, uh, 40, 50 years later, right? We're taking that mechanism, that underlying mechanism, right? And on top of that, a messaging mechanism, we are building software, right? That uses the same underlying connection, right? Listening at the same port 80, and being able to send messages. But then instead of using it for its original intent of retrieving HTML, ASCII documents, now we can implement our own logic, right? Where we can maybe connect to a database, retrieve data, right? Format it in a particular way, run some logic, right? And compute that result and send it back to the clients. Okay, and this is where we are today, right? What we have here is using a library called Express that allows us to, tell the server to listen at a particular port, right? We're listening at port 4000. You can specify exactly which port. Typically, in an HTTP browser server, right? The default port is port 80. It's like you saying port 80. Oh, no, 4000. And so we are programming, right, what should the server do when they get all sorts of requests, right? So for instance, in our examples protocol controller, right, we programmed that we could use the instance of the Express library. This instance, we pass it as an argument to the examples controller, and we can specify, right, what happens if the server receives a get, or a post, or delete, or put. And also the URL has a specific pattern, then we can run different functions, right, that can handle the different types of requests. Right. So for instance, if the URL has a specific pattern, right, then we send back a hello message. Right? And this Express library, right, allows you to create these handlers that handle the various gets and posts and puts and delete messages, and it divvies out the different types of requests and the URLs. The one that matches, it just iterates over all these patterns, and the one that matches, right, it passes and calls your particular function. Okay, so where we here is that we're sending hello. Here we're saying goodbye or that's good, or we can also parse from the path, strings out of there, convert them to strings, and then do some arithmetic operation. Right? So we started exploring and implementing certain features that we wanted for the application that we're building, right? And we moved here on the server. We're moving the responsibility of maintaining this data structure, right? This array of tweets. Now we already had done this maintaining this array on the client side, right? And so you might ask, well, if we're doing all this on the client side, being able to create tweets, delete tweets, update tweets, and whatnot, why are we replicating it here? And that's a legitimate question. And so we discussed some of the limitations of implementing this on the client, right? So that even though we can manipulate the data structure, we can push into this tweet, we can create new tweets, delete tweets, update tweets, right? Even though we can manipulate the data structure and the user interface that goes along with that, the limitation is that there's no place for us to make those changes permanent. And there's no way for us to remember, right, all those changes. Say if I turn off my computer today, come back tomorrow, right? There's no permanency, right, to our changes. So we need to move that manipulation of the data structure. We have to move it away from the client and put it somewhere where we can store it permanently. right? So that we can come back tomorrow and see that the changes were successful and still there. So definitely we can't do it on the browser. I mean, there are some small limitations, some small ways of storing it at the particular client, but they're not worth discussing. Instead, the way to go is to ship out that state and all those actions of adding and removing and updating and deleting, right, to notify someone outside of the browser who does have the capability of, again, manipulating the data structure, but making those changes permanent. Okay, and that's why we're creating the server. The server, this array here, it's in a file, and we load it here, and then all these gets and posts and deletes and puts, we are designed to manipulate this data structure, right? The state of that application, the tweets. And being a server running out of a desktop, it doesn't have the limitations of the browser. Right? It can make the changes permanent by perhaps writing it back to the file. That would be one way, right? Things that we could not do on the browser. We can't write to the file on the browser. Or, as we'll see next week, right, that we can make these changes permanent in a database, right, for long-term storage. So we don't know how to do that just yet. We could certainly just save this to a file right now, right, and make the changes permanent that way. But we're not going to do that. We are instead just going to load the variable into a local variable, and then make the changes at that level of this array, right? Just to learn the basics, right, of how this works, how to receive the messages, right, from the client. It's going to send us all these messages. It's going to want to see the tweets. It's going to want to see a particular tweet. It's going to want to create a tweet. It's going to want to update a tweet. Right? It's going to want to delete a tweet. So all these are the CRUD operations, to create, read, update, and delete operations that all data structures need. Right? So today we're going to focus on that part. Right? How is it that the client is going to talk to us here? Right? How is the client send us these messages? We are pretty much ready to receive those messages. Right? Last lecture we tested our application using Postman. Since we don't have a client yet, we don't have a React client just yet that can talk to this. Instead, we use Postman. So Postman is a tool that allows us to generate these requests, right, and see the responses coming back from the server before we have any user interface. Right, we still want to be able to interact with this server. So we tried out these different CRUD operations. Okay. Let's see if we can run this. Run it. Okay, so it's running presumably. Then we can come here and try out these requests, right, where we can retrieve the tweets. There they are, 3 tweets. That we can create a brand new tweet. Right, on Twitter, say send it. It's a post. And then we say find all tweets. We can see the new tweet added. Right, where create is same. Notice that it's sending to the same URL. Right, the retrieval of retrieving all the tweets and creating a tweet. Notice that it goes to the same URL, and the way the server knows whether it should create it or retrieve it, it knows because they're different. Right, the method is different. For finding and retrieving, it's using a get method, whereas to create new, it's using post. We also took a look at an example of using update, where we can provide the new values of whatever we want to update, right, as an object embedded in the body, right, of the request. Right? And also so that the pattern that we're following is that we have some kind of noun that represents the things that we're manipulating. In this case, these are tweets, right? And you specify, perhaps the ID of the thing that you are manipulating. So this 321 would be presumably the ID of the tweet whose ID is 321. You can retrieve an individual tweet, right, 234, and returns that one object, and delete, removes from the array that particular tweet. Okay. All right. Okay, so that's an overview of where we are right now. Right? So the intent would be, well, the question would be, well, how do we integrate this with our existing React.js? And that's going to be the focus for today. Now, one of the things that we'll need to realize is that some of the work that we've already done for maintaining state at the browser level, well, some of that's going to have to go away, right? Because we're not going to be maintaining the state at the application, at the React level. We're going to maintain it here at the server. The server is going to maintain the state. The client, the React browser client, what it's going to do is have a copy of that state. Right? It's going to go fetch the data from the server. It's going to copy it in a state at the client level, at the React level, and that which is going to be used for rendering the user interface. Right? So all this data is going to live on the server. The React.js is just going to have a copy of what that state might be, right? And then use that to render the user interface. Okay? So first of all, let's try and do this one where we want to retrieve all the tweets. Okay? So we are looking to refactor our React web app. So first, let's check to see where we are so far here. We have let's check our branch. Okay, so we are in A7 tests, and we are let's see, we're going to check out. Let's see where we are. Let's run this npm start. Okay, all right, so starting the Node.js React application. Okay, let's see. If we go to Twitter, right, it renders this Twitter here, and nothing else. Really, we didn't do anything else. Let's see. Create store. It looks like there was a store. Let's see. Twitter index. Do we have A7? Usually A7. First one we had A7. Okay. Explore. Okay. Where's that app? Let's see. Let's start from the beginning. Oh, this is public. The wrong place. Oh, here's app. Here's A7. Perfect. Okay. There's Twitter. Okay, that's empty. All right, that's good. Actually, we'll have a place to get started from scratch. Perfect. Excellent. All right, so here's where we were playing around with the state for the application state and the component state, and I believe that was here in lab number 7, right? And we played around with tweets, being able to render tweets from the reducer. Okay. All right, so let's get started there. Let's implement here tweet list here. All right, that's good. Yeah. Okay, so what do we need? What do we need? Right, so first we need a user interface that renders tweets. Okay, so let's do that. We'll need a component. Let's call it tweet list or tweets, not tweet list. Okay. And so we'll create that. So, tweet list that returns the tweet list. False. Oops. Tweet list. Okay. And let's render that in Twitter. And I'll just render it. Okay. There's a tweet list right there. And so this is supposed to render an array of tweets. But this array of tweets is where? It's here, right? It's in find all tweets. We want to do that. We're going to go fetch those tweets and render them right here. Okay. So let's do a quick and dirty way of doing this. Let's implement two versions. Let's do a quick and dirty version of this. So this is tweet list. First, let's do it the wrong way. Let's do it the wrong way first. Let me stop this for a second. First, we're going to implement, we're going to install a library that can retrieve data from the server. We need to be able to do this, what Postman is doing, right? That is doing here manually. We need to be able to do that programmatically, right? And so there's a library that allows you to do that. Okay. And so I'm going to do it the quick and dirty way first. So let's say new JavaScript. I'll call it tweet list quick and dirty. So const tweet list quick. Okay. What we want to do is that we want to go fetch that information. Tweet list. Okay. Export. Let's render them both, one below the other. Okay, they're both render. Here. Oh, start the server. So for the quick and dirty tweet list, what we're going to do is that let's declare here a state variable where we can store that array that we're going to go fetch from the server. So here's Twitter. We have the quick and dirty at the bottom, and then we'll do it the right way. But just to show you how easy it is to go fetch data, right, from the server and then render it. So first we'll declare a state variable that says tweets and set tweets, right? And we'll initialize this to a empty array. Use state as an empty array. Right, there's no tweets there. Obviously, we would have to maybe connect it to a reducer or whatnot. But again, this is good. And so what we want to do is that when this loads, when this component loads, we would love to have tweets list, right, be populated with the data that comes from the server, this array. Okay. So there's one way to do that very easily. We know the URL. If we know the URL, you can say fetch. Okay? You can put the string. See that? So let's refresh here and let's inspect and see what happens. We can take a look at the network connection. Let's say network and refresh. Okay, there it is. So in the network, we can see that there was an attempt from our component in the list quick and dirty to make a request to localhost 4,000 tweets. See that? So we were able to do it. Notice that if I comment this out and I refresh, notice that it does not make the query. See that? It's not generating the request. So definitely this fetch is trying to connect to the server, right, to that location, perfect. But it's getting a block, some kind of failure. And it's the other one as well, same thing. Okay. Also, it's doing it twice because in development for test purposes, right? There's a React strict mode, right? That you don't want that in production. Okay, for development purposes, it's great for debugging, testing, and whatnot, but you don't need it. So okay, notice that now it's just doing it once. Now notice that there's a course message status. There is a course error, and basically what it's saying is that it's a security breach that us running on port 3000 we're trying to connect to a server that's running on 4000. That's considered a cross domain. You know, you're trying to do a communication between domains, and that's not allowed. Okay? Unless you allow it, you specifically allow it. Let's do that. Let's specifically allow that. Let's go back to the server and say, hey server, if you see a command message from anywhere, it doesn't have to be from your domain. Okay, it can be from anyone else. Right? Please let it through. So let's first stop the server for now a little bit. Okay, let's see. I'm going to install a library. Called CORS. CORS stands for Cross-Origin Resource Sharing. Okay? And which we are going to figure to let the server accept invocations from anybody, from any other domain. Right? You could be specific. You could say, well, only these domains can talk to me, right? And just ignore all the others. But we're going to be lazy, and we're just going to allow all domains to talk to us. So we're going to import the course library that we just installed. And then right here, right after we create the express.json, we can say app.use.course. That by default, it opens up this server to anybody who wants to talk to us. And we're not going to reject calls from other domains. Okay, so let's restart the server. And it has to be in this order. Right? It has to be one of the earliest things that you do right after instantiating your app. That means that you are allowing everything that comes afterwards, right? You are allowing it to come through. So for instance, if you put this in the middle here, you're saying that you are not allowing this. So that nothing that comes before it is going to be allowed to receive cross-domain communication. But everything that is after, of course, is going to allow communication. So this has to be one of the earliest things you do right after instantiating the app express instance. So let's start the server. The server is up and running again. Let's go back to the browser and let's refresh. You notice that this time we did not get an error. Did not get an error. It's not red. And if we look at the raw response that comes from the server, it is indeed the data that we want. Yeah. We can preview it, right? All parsed in object form. Right? So it is the data that we want. That's as easy as you can get with those fetch data from the server. Yeah, so there it is, pretty quick and dirty. Now, how do we? Now we have to put this data that comes back into the streets. Okay. So how do we do that? So first of all, let's put this inside of a function that we can call maybe find tweets, get all tweets. Function like that. Put this in there. Now if I run this again, notice that it's not being called. So we need to call it. When do we call it? We want to call it when this when the component loads. So how do we know when the component loads? You might say, well, I can just call this function, right? And then what would you do with that function? What would you do? Well, you could save the tweets that comes the data. Actually, no, this comes back as some kind of response comes from the server. A response. In that response, okay, we need to parse out the data from that response. One of the problems that we have is that these requests that go out to the server, they are asynchronous. Asynchronous in the sense that when you get to line 6 and the fetch is invoked, okay, when you get to the next line, say you try to console log response, okay, this call is asynchronous. Fetch is asynchronous, and what it means is that the thread, the JavaScript thread, is not going to stop here to wait for fetch to complete. Right? It behaves differently. Right? Normally, we think of functions being invoked synchronously, meaning that the function, until the function does not complete, we can't advance to the next line. Not here. This is asynchronous. And so that means that we're going to get to try to render or console log the response before this comes back. So we're going to execute line 7 before this fetch comes back. So response will be undefined by the time we get to console, because it's not going to wait. So how do we do that? So the way we do that is as follows. You can say async. You can tag your function as async. And then you can tell this to actually wait as if this were synchronous. Okay. There's a lot of magic that happens behind the scenes from here, but I'm not going to get into that. Once you have a response, we can now parse the content. But let's see what that is. Let's see what's in there. Okay, so let's refresh. There's our tweets that we fetch the data. Let's see what the console displayed. Look what it displayed. It displayed a response object. See that with headers, status, right? Where the URL went out. Okay, but no data. The data is actually here in the body. The data is a readable stream that needs to be parsed. Okay, that parsing is also asynchronous. And the way we parse it is as follows. Say await response dot JSON. JSON is going to do the parsing for us. Dot JSON is going to parse the body. It's going to stream and capture all the data that's coming back. And it's going to convert that into a JSON representation. That string that is streaming, convert it into a JSON representation. And then we can just print out data. Let's see. The data there. See the data? It's the actual data that comes from the server. Once we have the data, then we can say set tweets right with the data. Now we have the tweets here, or do we? Okay. Notice that if we say here render the tweets and maybe the length, okay, it's rendering 3. Look at that, yeah. And do we even iterate over it? Say maybe well, and maybe iterate over the tweets.map, and maybe align it, and render the tweet. There it is. See that? Okay, so we have the data and we render it. Okay. All right. So one problem though. There is one problem. There's no guarantee. Okay, it's working now because we have the server and my browser. They're running on the same machine. Okay, and oftentimes this now if the server was running halfway across the world, there could be a lot of latency between me going to fetch something, right, and then me having the data to render it. Okay, so to guarantee that there's synchronicity, that this gets called when this gets loaded, right, we need to do one more thing. Just like there's a use state for maintaining state, there is also another hook, right, that gets invoked when there is this component first loads. Right, so this is a bad practice of just calling this function like that. Instead, we're going to wrap this in a use effect. Use effect is another hook that guarantees to be invoked not only when we load, but if the data ever changes for some reason, right, it would cause this to rerun into re-render itself. Right, so use state takes 2 arguments, function, and an array that you can specify things that if they change, then it would cause this component to change, to re-render, right, or rerun or reload itself. So use effect controls when this component needs to update itself. Right? And so and function is what gets invoked. They can be guaranteed to be invoked whenever things change, like when you first load. What do we want to do during the first thing? We want to put a get all tweets from server. So now it's okay. And now we can guarantee that it's going to go out, right, and that data is going to be rendered, right, and called when this loads. All right, it's complaining about the keys. And so whenever we are dynamically rendering a map, right, remember to put the key here. That is not that this value needs to be unique identifier, and then it should not be playing. There. All right. Okay, so there was a quick and dirty implementation of us retrieving data from our server. Let's see, is there a question in the chat? All right, let's actually do it the right way. Let's do it so first of all, we don't have here a reducer. We don't have any of that. So let's do it the right way. Let's create a reducer. Now let's implement it here in the twig list. Okay. So let's create first a reducer. So this might be tweets reducer. Okay. And so you're going to initial state is going to have not only their tweets, it's going to be an empty array, but because we're going to go out to a server, and the server might take a while to retrieve data, we might want to perhaps put a spinner, right? That's that might be taking a while to fetch the data. So let's put a loading here that we could maybe maintain depending on whether we're still waiting for data to come back from the server, and we can maybe display a spinner or something. Okay. And the actual tweets, these are what we're going to get from the server. Let's create a slice that comes tweets producer. It's going to create a slice. And remember, the slice took two arguments. One was name called tweets, and the second was the initial state. Remember, this syntax means that initial state is colon initial state. But if the property name and the value have the same exact spelling, you can compress that into just initial state. Okay? And we're going to export default the tweets reducer. Okay, from that. And then in the index, we're going to create a store that we're going to provide the store, right? So on store, and using the configure store that, you remember, takes an object that whose first attribute is the reducer, which is another object that allows you to create multiple buckets of data that can be populated by the various reducers. And perhaps you could have a different bucket per screen. Each screen has its own the data that it needs. So, for instance, let's say the tweets data, right? We're going to populate that with the tweets reducer. We need to import that. There it is. The tweets reducer is going to be responsible for populating the tweets data, which initially is going to be equal to this object right here. So now the tweets data includes the tweets and the loading flag. Okay. And maybe we can put some initial values here just for default values. Let's see, maybe we can use the ones that we use for the server. It's this one. Maybe we can use these here. And just to distinguish them from what's on the server, let's put it in there. And then we bundle all these 3, 2, 4, 2, 4, 5. Okay. Just to distinguish them from the server. And now that we have the store, we can provide that store to the rest of the application. Say provider store. Okay, now everybody in here is going to have access to the store. Okay. In particular, the tweet list. Can retrieve the tweets. Can retrieve the tweets and the loading from the use selector. So state here, the state object is this whole thing. And it is this whole thing, this whole object, all of it, of which we can just extract the part that we care about. And say, I don't want the whole thing. I only want this part right here. So now this object here is what? is whatever that is. What is this? So this is whatever the tweet reducer generates. What does it generate? Well, it starts off with the initial state, which is this whole thing. So this here, so this tweets gets what value? It's this value. And this loading, it's that loading. See that? Okay. So here we should be able to say if it's loading, we say well, and we can just render this. Say it tweets app tweet. So we can render that. We can render li I like this would be tweet. Maybe this would be the key. Be the tweet dot. Right. And there they are. Right. So this is the data coming from the reducer, right? Not from the server. Not from the server. We'll populate with the server in a minute. Okay. Maybe we can paint this a little bit prettier. Say this is a list group, and this is a list group item. List group item. So that's a little bit more presentable. Okay. All right. Yeah. And maybe if it is loading, we say that if it is loading, then we can programmatically add another li. This group item. And say loading. Which right now it's false, that's why it's not showing. But if it were true, this were true, then it would display this loading right programmatically. So we know that works. Okay. So how do we fetch this? How do we fetch this? So we still have the issue of the communication being asynchronous. So what we're gonna do is that a good practice, instead of what we did here, this quick and dirty, we said, oh well, here I just need data. I'm gonna go fetch it. I'm gonna go grab it. Okay, that's a bad practice. We should not do that. Right? Instead, what we should do is all the various operations with the server, they should all live in one place. Right? Provide a nice little API, maybe little functions, right? That encapsulates all the different things that we want to do with the server. We want to go find, fetch all the tweets. We want to create a new tweet. We want to delete a tweet. We want to do a whole different things with the tweet. So all there should be one place where all that lives. So there is a design pattern that says that what you should do is create a dedicated server. So it's the JavaScript for the tweets service. Okay, that's going to declare all the functions that we want to do to talk to it to the server. And say, find all the tweets. So it's going to have it does that. We want to serve. I want to create. That's going to keep it. That's going to run this. I want to delete. And then you do that. Or maybe I want to update it. And then the update and anything else, right? Maybe a like, an unlike, a retweet, a reply. So all the commands would live here, right? And all these functions would be responsible to talk to a server. and then convert these function calls into a copy to the server. So, so to talk to the server, we need to know where the server lives. So we're going to copy that and just put it in constant and say tweet URL. All right, so what would find all tweet do? Well, it would do pretty much what we did here. So it's just basically this function. So let's do that. And we'll say, and this one right. But in this case, instead of set tweet, it's just going to return. Say return the data. Expression expected. Expression expected. Oh, it's supposed to be async. And this fetch would be instead this tweet URL. And maybe a better name for this might be tweets. So now that we have this, when do we invoke this? What we want to be able to do is to invoke this when. Let's see. We want to invoke it when this component of tweet list gets loaded, right? But we want the data to end up in the reducer. Okay, so somehow we need to dispatch, right, and let the somehow say that unload use effects. Unload. We need to let the reducer say, hey, I'm loading. I need this data. Go fetch it. Go get it from me. Okay. Now the way we did it in the quick and dirty way is that we call this function locally to go fetch it. But instead, we want to call what function? So here we want to call which function? The service. This service right here. We want to say, I want to find all tweets. Call that function. I want to call that function. But I need that function to pass the data to dispatcher. Dispatch the the reducer. The reducer needs to receive this information. And so somehow I need to dispatch this. So we can grab the dispatcher, dispatch from use dispatch. And we want to have this being some kind of action. We need to be able to declare here in our reducer some kind of action. Remember that we say reducer. That we need to declare some kind of reducer that we can call, right? And then it updates the data. That's what we want to do, right? So declare here some reducer and find all these, right? And these functions somehow state that receives new state, right? And here's the action. And then somehow I need to maybe say state, which is the tweets. Oh, sorry, I'm putting it in the wrong place. Sorry, not here. Sorry, in here. In the slice. Right, we would update the state dot tweets, right, with some action dot payload. The problem with this is that these reducers, these functions in the reducers, they are synchronous. They cannot be asynchronous. Okay? They cannot be asynchronous. That's the problem. That's a big limitation. these functions have to be pure functions. They cannot have async, await, or anything like that. Okay. Raghu, can you not hear me? Hello? Am I speaking too loud, maybe? Oh, you can hear me now? All right, I'll try to speak a little louder, a little much more clearer. Some water. Yeah, so that's a big thing. So I cannot call this. So it'd be great if I could somehow, I find all my tweets, right? And I call this find. So this is the service, right? This is the service, and that service needs to call. Somehow I need to do a dispatch of final tweets. So final tweets. Now this final tweets would be this final tweets. But then there's a service that needs to be called to actually fetch the data, right? So we cannot use that. We can't do that. So what can we do? So there is a mechanism by which you can do asynchronous communication, right? Where you have reducers, but they can be asynchronous reducers. Okay? So we're not going to do this. We're going to abandon this. Instead, there is extra reducer. See that? There's extra reducers. So what extra reducers do is it's also an object where these reducers can be asynchronous, right? They can use what are called thunks. A thunk is a function that can be invoked at a later time, right? Where they say, okay, well, when an event happens, right, invoke this function, right, asynchronously. And so we need to create these thunks, right, that are going to wrap these service functions. They're going to wrap them up and say, well, at some point, these functions are going to be invoked. They're going to run asynchronously, and then they are going to provide the state that we can then populate into this reducer. Okay, so let's do that. Let's create a thunk. So right here in the service is going to create the tweets thunks. So JavaScript, this will be tweets thunks. Okay, and we're going to create a thunk for each one of these functions, for each one of the services. There'll be a thunk for each one of these. So there'll be a find alt tweets thunk. There'll be a create tweet thunk, a delete tweet thunk, and so on and so forth, right? And what they're going to do is they're going to wrap these services. And they're going to be able to participate in the various states of the network communication, right? We're going to be able to say, hey, has this request been fulfilled yet? It says, well, not quite yet. It's on flight. It's in flight. Right? We sent the request to the server. It hasn't yet been fulfilled. Okay. So for instance, that would be a perfect time to turn on the loading. Right? We could turn on loading to true. Right? We could start at false first. But if it's in flight and we haven't yet received a response, that would be a perfect time to make the loading true. And then when it is fulfilled and it comes back, then it would be a good time to make this true, false again, right? So, and then we can turn on and off the spinner and whatnot. Okay. So let's do that. Let's create a thunk. Let's create the thunk. So we'll say const is find all tweets thunk. And the way you create a thunk is to use a create thunk, asynchronous thunk. Okay, there it is. And basically here is a function where you oh, where is it? It takes two arguments, right? So the first argument is a name, a unique identifier that this could be arbitrary, but it names the thunk. So, for instance, it might be tweets, okay? All tweets, or yeah, that's it. That's going to be just tweets. And the second argument is the function that you want to invoke. So, the function that we want to invoke is the service. Is to find all tweets in our service. Now, all tweets. Yeah, this is the service. Did not import it. Should have imported it. Import. Actually, let's put it in. Fine. Did I export it? Oh, I didn't export it. That's why. Export. 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 Let's try it again. It should have imported automatically. Say fine. All tweets. There we go. We want to call that. All right. And let's see. Great song. I think I'm missing something. This is great song right here. This is that function. And I think this is async. And we're going to call this. And this is going to be this is going to receive the state. Oh no, it's not going to receive the state. Just going to be just like that. Let me see if I'm missing something. Let's see if I'm missing something. This is a good introduction to the assignment number 8. You're going to use this for assignment number 8. Oh, okay, yeah, so it's just a function. Async, blah, blah, find, wait, and it's going to return that. So it's just going to return that. And let's see, why is my syntax, why is this rendering so quickly? There we go. Okay. And let's also export this so that we can import it. Export. So this is just basically just wrapping our service invocation inside of another function. Okay, that this function is going to be invoked at a later time, and it has several states of whether this thunk has been fulfilled, whether it has been aborted, whether it has been rejected, whether it's in progress. Okay, and then we can use that logic to be able to drive the different states. And so, for instance, in the reducers, right, we can create now based on that thunk. We can import it. We can import this thunk into this thunk, right? Dot. Notice that it has states. Whether this thunk, when it gets invoked, whether it's still will it have been completed, whether it's still pending, whether it's been rejected. So for instance, we can say it's pending, right? It's pending. Then here we have state, the payload, the action, just like we have here in the producer. One of the things that we might do is that if it's pending, if it has not yet been fulfilled, right, then we can change the state of loading to true. Whereas the state of the tweets, we don't know what it is, so we're going to just make it empty. But if it has been fulfilled, we have the find thunk has been fulfilled. Then we can say that we have the state of the action. The action will contain anything that the thunk returns. So what are we returning from the thunk? We are returning whatever the find all tweets returns, which is the tweets. So here we can say state dot tweets is equal to the action dot payload. Payload is the tweets that keep back. And since we receive now the data, we can say that the loading is false. Okay. All right, excellent. So once we have that, we can now go back to the tweet list and do the dispatch correctly. Like, we're going to dispatch. We're going to dispatch the thunk. Right, we're going to invoke the thunk. Right, the thunk will invoke the service. It'll go out to the service. It'll come back. It'll return, and we'll put that in the payload, and will then be invoked here depending on the state and whether it's pending or it's not yet done. Right? It will initialize our state, loading to true, and it will empty the array. And when it's done, then we'll turn off the loading, right, and update the array of the tweets from the server. Okay. So let's try this out, see if this blows up. Okay, so you'll notice that already we see that this is data that's coming from the server. And notice if I refresh, right, this data is coming from the server. Remember that in Postman, we did check to see. Notice that this is indeed the data, the array that we are generating from the server. Tweet ABC, tweet XYZ, and so on and so forth. Right? Tweet 321. Make sense? Now to make this a little bit more interesting, right? We go back to the server, and we have that controller. This is the tweets controller. It's returning right here, right? Get all the tweets and sending back all the tweets. See that? So just to illustrate or simulate if there's a delay, right? Right now there's no delay because my server and my browser are running on my same machine. But in reality, this could take half a second, maybe a second. So let's dramatize this, okay, so that it takes maybe 2 seconds. Okay, so we're gonna create a timer. We'll say set timeout, and so we're gonna wrap this in this function. So we're gonna call the response.send, but we're gonna call it 2 seconds later. So we're gonna wait 2,000 milliseconds, and then respond. What if you ask for the array of tweets? Okay, so let's restart the server here. I just wanted to illustrate what would happen, right, if this waited. So let's go back here, browser. I'm gonna refresh. Now notice what happens is, see that it's displaying loading, and then 2 seconds later it displays it. Okay. Now notice if I refresh again, there it is. It's loading, right, and then it displays it. And what's happening here is that so when the request goes out and we haven't gotten a response yet, right? This function that is being invoked here in React.js, that the thunk is still pending, right? It has not been fulfilled, and we can change the state accordingly. Now, when it has been responded by the server, this function will be invoked, right? And we can update the loading and the array of tweets. Make sense? All right, so those are the thunks for retrieving the tweets. Right? So let's play around with some of the other things that we need to do. So in the service, we need to be able to create it or delete it. So let's play around with deleting a tweet. So the URL for that, right? Well, first of all, we're using fetch. So fetch is an out-of-the-box function that is standard in the JavaScript language, but it has a couple of shortcomings. I'm not going to get into. It is more common that folks use in production. They use another library for talking to the server. Right. So let's install that. Yeah. More common library to use is that Axio. Right. So let's do that. We're going to do npm install Axio. But sometimes you'll see folks using fetch, but it's more common that you use Axio. So I'm going to rewrite this. Instead of fetch, I'm going to use the Axios library. So I'm going to say Axios. It's going to be imported. There it is. So Axios, the way it works is that you say dot get if you want to send a get, which in a fetch is the default thing to happen. In a fetch, if you want to fetch something, you just say fetch, and by default it sends a get. Here you have to explicitly say that you want to send a get. That's one of the differences. The other difference is that the response already contains the parsed string or stream that comes back from the server. It's already done. You don't have to explicitly go and stream it and accumulate it and whatnot. So instead, there's no wait here, and the data is actually available in dot data. Right? And you don't need to parse it or stream it or whatnot. Okay, there's no wait. So we could just maybe respond with this. We say return response.data. Okay. So let's see if this still works. Let's refresh. Let's see if we can break anything. Oh, there it is. Okay, so let's implement the delete version of this. Let's go in back to the web app and let's create the well, first the delete. The delete, remember from Postman, the way we implemented the delete was that we sent out a delete, there it is, the delete, to this URL, and we appended the ID of the tweet that we wanted to remove. So basically, we said wait. Oh, this needs to be async first of all. We add that async. Await. So this you can only use await keyword inside of a function if you tag it as an async function. So you can't use await unless you put async in front of the function. So we're going to do an Axio dot delete. So we're going to send a delete message to the tweet. Now the tweet, we need to append the ID of the tweet, which we have right here. So we can do that by putting this in a string and then expression. We're going to append at the end the tweet ID expression. So tweet ID. Putting at the end. See that? Now this is going to come back with some status. So this, well, the response. Here's the response. And then we can just return the data in there. Now I'm not quite sure what we sent back from the server. And what do we do in the server? The server, when we delete, we respond. Oh, just 200. We just said 200. Maybe what we could do on our end, probably it's convenience to not just because the data is going to contain just an OK, right? So just useless status. Right? So one thing that might be useful is to return just the ID of the tweet that we just deleted. Might be useful for the user interface. Right? Maybe just remove it. Let's wrap this in a thunk. Let's go back to the thunks and let's create a thunk for the delete. So export const delete tweet thunk. Create a thunk and unique identifier. So delete tweet, and then async. We're going to invoke the delete tweet function, and we're going to pass as an argument the tweet ID, and we're just going to pass it along. Okay. And this is going to be an overlay. Now remember that this is a shorthand for this, right? This is shorthand for return, right? Which is what I wrote here. But since this is the only thing I'm doing, I can just do this and remove the close bracket. Right? It's much more concise. So we can. When do we want to do this? We want to do this when you click on next, right next to a tweet. We want to pass in to the thunk. We want to pass it the ID of the tweet that we want to remove. So let's do that in the tweet list. Right, for each tweet, right, we're going to render an X, maybe a button that says delete, and the last thing, button, danger, right? Maybe send it over to the right, so we put it at the end. And so if we click this, unclick, and we want to do what? We want to dispatch the delete thunk, and we're going to pass it the tweet ID. And it's this tweet ID that we have right here. We'll pass that. So that's going to call this guy. It's going to pass it the ID. It's going to call the service, delete tweet with the ID. And so now we need to make that into the reducer. So in the reducer, we're going to have a delete tweet thunk. And here we can also do pending, fulfill, blah, blah, blah. But I'm not going to do the pending. I'm just going to do the fulfilled. Fulfilled. When the thing is done, action. So what's in the action? It's whatever we return from the thunk. What does the thunk return? Whatever the delete tweet returns, which is the ID. So that's what's in the payload. That's what's in the payload. So action.payload has the tweet ID. So we can extract that, say, using a destructor. We can retrieve the payload. And so we can say, what we could do is just remove that tweet from, well, we removed it from the server. Locally, in our state.tweets, we have the old tweets. Okay, so there's two ways that we can go about it. We know that we deleted it from the server, but we have a stale copy from an old time that we went to fetch it. So we kind of have like a cache version of that. So we can update that cache, or we could just go fetch that array again. That would be too expensive, right? To just fetch the whole thing. Instead, what we're going to do is we're going to update our local copy. We're going to say state tweets, and let's see. We can find the. What can we do? Let's see. We could just maybe filter out that tweet. Let's say state.tweet is the old state.tweet, okay? Filter out, filter, there's a tweet, and I'm only going to keep the tweets if its ID is not payload says, right? All right, so let's see if that works. All right, now, so we're going to keep this network open because presumably we're going to be sending a delete message to the server, right? And so we want to make sure that that does go out. And the front end, right, in the UI, presumably is going to remove that from this array. Let's see, delete. Okay, all right, that was a little too easy. It did remove it from the local one, but let's see what happens to the server. So let's see. Okay, there was a delete that was sent out from the server to the server, right? With we encoded the 1, 2, 3 at the end of the array. That's the URL. And okay, notice that there's 2 requests, right? So one request is options. See that? This is kind of like the browser asking for permission to the server. Hey, server, are you okay with me sending you a delete? And the server is responding, yeah, these are all the methods that are allowed. You can send me get, put, post, delete. You're good. You can send me a delete, right? And then this is the second request that goes out to, okay, well, then here it is. Here's the delete. And this is actually we can do this, right? Because we turned on CORS on the server. If we hadn't turned this on, right, the server would have responded, nope, I'm not accepting anything, so sorry. And the browser would have failed this request, saying, oh, sorry, there was a CORS security, blah, blah, blah. You can't do that. Okay. So yeah, so this looks like, if I refresh, notice that it's loading, right? See that? And now, see that? It's permanent. Our delete is permanent. If I refresh, if our browser refreshes, it's not like before, last week, right? If we refreshed, kind of lost the state, right? Because we had no place to make the changes permanent. Instead, we are making it permanent, quotations, right? In the server's memory, right? In the array that is the server is maintaining. Okay. Yeah, that worked. Let's now create a new tweet. How's that? Let's do that. So let's see. In the tweet list, let's create maybe a line item here where we can maybe put an input field. Say line item class list group. Let's item, and let's put maybe a button where you say tweet, and say maybe make it blue. Button primary, maybe we'll push it over to the right, load it to the end. Okay, there's my tweet, maybe an input field in front of it. And input, and we'll keep this a little nice with form control. And so notice it's too big. It's too big and kind of like wraps. Let's make it a little bit shorter. So say the width will be 70%. There it is. So now we can type here on the tweet, and maybe we can have a placeholder that says what's okay. All right. So let's see. What we'll do is we'll have a small little state variable that has a tweet text. So set tweet text, use state. It's going to keep track of our text that we're going to be typing. Yep. So our input field is its value is going to be this new variable right? Tweet text, and we're going to, as we type on change, we're going to take the event, we'll set the tweet text to be events target value. Okay. So now we can just type. Now if we press the tweet, if we press the tweet button, we're going to unclick, we're going to dispatch the delete thunk that we created. No? I'm sorry, the create or the tweet thunk that doesn't exist. And so we need to create the thunk. Yeah, right. We need to create the service. We need to create the thunk. We haven't done that just yet. Yeah, let's do that. So let's go into service. So how do we do this on Postman? So in Postman, right, to create a new tweet, we did what? We did a post to that URL, and then we encoded the object in the body. All right, so let's do that. So we're going to say response, right? I guess this is the sync and wait Axios dot post, send a post to that tweet URL, and we're going to send some data. Let's put some data here. So I'm just going to. So what are we passing? So we have to decide what we're passing. Are we passing an object, or are we passing the text of the tweet? So I'm going to go with the text. I'm going to pass the text, right? And so we send an object to the server, and the object will be something that looks like that, right? Something that looks like that. That has a property tweet and then the text. So this has to be tweet and then the text. So that's going to be sent out to the server. Now the server comes back with what? What do we return from the server? From server, here's our post. There's our post. We return 200. It would be very convenient if the server would return the actual object that was created. That would be very convenient, so that we could then update the user interface with that new object. That would be very, very convenient. So let's do that. Let's restart the server because we just updated it. Terminal, stop, run it again. So back on the client, we're sending that. So now in the response, if we return the response.data, that data is going to be what? That's going to be the new tweet that we just created, right, on the server. Okay. All right, so let's create the thunk for this. And so it will be export const create tweet thunk, create a sync thunk. So the first argument is the name for this. So create tweet. Then async. And so here we're going to pass the tweet text from the user interface. I'm going to pass it to the create tweet from service, right? Create the passive tweet text. And what is this going to return? The actual object tweet that was inserted in the array, right? Obviously, we can always rewrite this to be more concise. Okay. Maybe split this into 2 lines so that it's a little more readable. So now with that create tweet thunk, we know what we can call here, right? We can call the create tweet thunk. We're going to pass it the tweet text that we've been editing. Right? Maybe split up into 2 lines so it's a little bit easier to read. Now in the reducer, right, we can create a fulfilled here. Create thunk.fulfilled. It is fulfilled then the payload is going to contain what? The actual tweet that was added in the server. So we can say that state that tweets, we can push this new payload, right? All right, so let's see if this works. So if I tweet this, notice that it has been added. We can refresh and see if it's there. There it is, right? So if we go to Postman and we retrieve all the tweets, should show here too. If I run this, if I send this, there it is. See that? There's a W tweet that we added here. So we said, Elon bought. Okay, we sent it over. And then we said Elon should bought instead tweet it. There it is. Okay. So we go back here and refresh. We sent that get to the server. Now to point back, see that those tweets are permanent, right, in the server. Obviously, if we restart the server, right, we would lose those tweets. But not the case next week. Next week, we will be saving it to a database permanently for long-term storage. All right, so we can create, we can delete, we can retrieve a tweet. How about editing tweet? Editing tweet. How about maybe I want to be able to like a tweet. Okay. So on the server, what do we do on the server? Let's see. So on the server, we do a put. We send the updates. We send the updates, and then we find it. We update the object in the array. We merged it with new, the old one with the new one, and then we send 200 or 44. Okay. So yeah, so knowing that, let's go back here. And let's see, to update, maybe we'll do a likes. So in the list, maybe we can put a button here where we can say that we like the tweet or not. Say button. It says like. And this is class. And this says maybe it's a button. Success. And load it to the end. There's a like button. Oh well, not here. I'm gonna put it in all the tweets. Put it maybe here. There it is. So like. So what we'll do, I don't know. Do we have any likes? Yeah. Do we have any likes? No, none of them have likes. None of them have likes. So what we'll do is that let's see. If we like, we'll do unclick. Let's say like tweet. Pass this tweet object. So we'll handle that here in a function over here. Say so const tweet, like tweet, and here's a tweet that we're liking. So what should we do? Let's see. What we should do is we could update the tweet right here, right, and maybe change its flag to liked, and then maybe increment the number of tweets of likes, right? Presumably it might be in the tweet. So let's say we could say tweet dot liked. We say true. That's been liked. Now so tweet, you say tweet dot likes is equal to what? Well, it could be that nobody has liked it yet, so we can say tweet dot likes. Are there any likes? We say is it equal to, is it defined, right? Is it defined? So we can check to see, are you even defined, right? We say type of, if it's undefined, then we say what? We say tweet, we return it to 1. This is your very first time somebody liking this tweet. Or it's whatever tweet likes was plus 1. Okay. Yeah, okay, so that looks good. We have updated the tweet. And now we need to dispatch it and send it over to a thunk. That doesn't exist, right? So let's create the thunk. Let's create the update, right? So let's do that. Let's create the service. So the service in the update needs to do what? We need to do the same thing, response. Wait. Oh, this is sync. Let's see. This is gonna wait. Question in the chat. Wait. We say Axios dot put, and so we're going to do the same thing that we did delete. We're going to encode the tweet ID as part of the URL, and this is the tweet ID, and we're going to send the tweet updates, which includes the new liked or the count in the likes, right? The initialization of the likes. So that's going to go out to the server, and then the server is going to respond with what? What is the server going to respond with? Well, let's see what it responds with in the server. Server, what's it doing? Put blah 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 blah. Oh, it's just sending 200 or 44. So what I'm going to do is that I'm just going to send the actual object of the tweet that has been updated, right? Merged and everything. Right? I'm just going to respond with that, and I'm going to restart the server. Whatever we decide to do, right? It's our protocol, right? However, our API works. And so to do that, we can now go back here, and whatever we return here, we're going to return the response.data. What is that data? Is the tweet that has been modified, right? Has been modified and made permanent on the server. Okay, so now we can create the thunk around that. Create the thunk around that. Let's say export update tweet thunk. Create the async thunk, and we get rid of the unique identifier. Update tweet. So this is the function. So we're passing two things here, right? The tweet ID and the tweet updates. And we're going to pass that. We're going to pass that to the service, the update tweet, TID, and the tweet updates. Okay. And it's going to return, what is it going to return? The actual tweet updated. So in the reducer, we can use that thunk to update tweet thunk when it's fulfilled, when it's done updating. The payload is going to contain what? The updated tweet or an error. So now we need to do what? We need to just replace in our user interface. We need to replace the that tweet with the one that counts back to the server. We can say, so we need to find it first. We can say const tweet index, and we find it by the ID, right? So we can say, state dot tweets dot find index of the tweet, and I'm going to return when the tweet dot ID matches the payload dot ID. That's going to find it in the array, and once I find it, I can update the state sub of state dot tweets, right, sub tweet index. I'm going to replace it with the payload. Okay. Yeah, so let's see. And now how do we know whether it worked or not? Say, we can say maybe, that's a quick one. In the tweet list, you can say that this button that you used to like, where's the button? Like this button that you like can only be shown if you don't already like it. Right? So we can say, if you tweet dot liked, if it's already liked, then you can't like it again. So the button will disappear, and that way we know if this worked or not. Right? Okay. Let's see. Let's try it out. Oops. Oh no, I'm sorry. If it's not liked, if it's not liked, then it would display. There. Okay, so like. So let's try it out. Let's clear out the server. Let's click on like. Uh-oh, something went wrong. Let's see the console. Cannot add property like yada yada yada. Object is not extensible. Wait, what? Tweet list yada yada yada. Oh, okay, so fine. Tweet. Oh, tweet. Let's say this. Oops. Is that probably tweet? Oh my goodness, let's put a breakpoint there. Let's put a breakpoint right there. Let's do that. What does this tweet look like? Tweet, blah 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 blah. It's not letting me update it. Why are you not updated? All right, I'm gonna debug this, and I'll fix it and make it available for everybody. I'm gonna push it to GitHub, and hopefully both the server and the client. And then you can use that as a guidance for starting to get to work on the 8th assignment. I'm almost done tweaking it, not quite yet, but you should be focused on finishing up assignment 7 for this weekend, and then you can get started on assignment 8, which will have this source code for you to play around with. Okay. All right. Any questions? Are you holding officer? Ooh. I don't believe so. I think I'm gonna have to push that to 2 o'clock tomorrow. Do we have a quiz this week? So I seem to have. I'm not quite sure why the quiz 5 is kind of misplaced. I need to find it. I don't know why it's not there. Somebody accidentally removed quiz 5. Hopefully I'll have it back there, and I will make it available when I find it. It should be, I think it should be available on Friday, so that you can, complete it over the weekend. Yeah, I'll make a post. All right, anything else? All right, everybody. Good night, everybody.